Here is question 1 on paper 2 formative for AASL, sequences in series and binomial theorem. So the question goes, on the 1st of January 2020, Lori invests P amount in an account that pays a nominal annual interest rate of 5.5% compounded quarterly, 4 times a year. The amount of money in Lori's account at the end of the year follows a geometric sequence with a common ratio R. So looking at this problem, we can recognize the fact that there's a compounded interest, which we have the formula of in the formula booklet, and the fact that there's a geometric sequence. So the first thing we're going to do is we're going to write down both of these equations that are derived straight from the formula booklet. So as you can see, there are quite a few common factors in between the both. As you can see, PV here, the original amount, can be viewed as U1 because both of these talk about original amounts. Furthermore, you notice how there is an N here, which is the amount of times this is compounded, and N here is the amount of time a geometric sequence is repeated. So these N's both have the same value. As you can see here, U1 and N minus 1, in between there's R. So in this case, this right here would be R, because this would be our U1, this would be our R, and then this would be our N minus 1, if we bring them here. Bam. Now, we're not done just here, because we're actually looking for the value of R, giving your answer to 4 significant figures. To do this, we have to input all the information up here into this formula. Just the part of R, because we're just looking for R. So we know 1 plus, that doesn't change, R is going to be 5.5. Since it's compounded quarterly, that means that it happens 4 times per year, which means that, therefore, K will equal 4. This K right here, and this K right here. K equal 4, so that will equal 400. What is this? K equals 4. Once we're here, we have to solve it to get full marks on this question. To be able to find this value, we have to put this inside of a calculator. So let's do it together. It's going to be 1 plus 5.5 over 400 to the power of 4. Perfect. This is the number we get. However, we have to put this to 4 significant figures, so it's going to be 1.056. And bam, that's how you answer the first part of this question. In the second part of this question, we can see that Lori makes no further deposits to or withdrawals from the account. Find the year in which the amount of money in Lori's account will become double of the amount she's interested in. So, we don't know the actual amount she's put inside. We only know the interest. But we know that her amount, as shown previously here, is shown through the letter P. So if she has double the amount, that's just going to be 2P. Now we have to make an equation with inputting 2P. And plus, we're looking for the amount of years, which means that our N is going to be unknown. So when we're formulating this equation, we have to put P, because that's the original amount, the R that we found out in the previous one, and to the power of N. So I'm going to write that down. So we know that 2P equals P perfect. As you can see, this is going to be our R. R, this is N, this is the amount of years, this is what we're looking for. P is the original amount she put in, and then 2P is the result we want. So we're looking for N. So now we have to do this in the calculator. I have a T184 plus CT Python edition. So you do this by going to Apps, Finance, TMV Solver. And here, we don't know N yet, so we can ignore it for now. The percentage is going to be, you know, that 5.5. We're going to put the present value, we're going to put it as 1 because we want it to be doubled, so it doesn't really matter the amount, even if we don't know it. We have to keep PMT as 0. Keep that as 1. PMT is 0, however, FV is going to equal -2. And the reason this is -2, it's not going to be -2 in your actual equation, but this is how this calculator works. Because if the present value is positive, then the future value has to be negative, and if the present value is negative, then the future value has to be positive. So ignore the the negative signs on these, except for if you're doing something with negatives. But like, yeah, you just have to do that, otherwise they're going to say syntax error. PY stays 1 at all times, and then compounded yearly, we know that it's 4, so 4 is already there. Perfect. Now, we are looking for N. So you can see N. Now that we're on N, you're going to press alpha, the green one, and then enter. It's going to give us an amount, 12.689122. So let's just round it to 1 decimal. Perfect. Now that we have the amount. However, they're asking us to find the year. We know that her original investment is done in 2020 because of the previous question right here. So what we have to do is we have to find 2020 and add 12.7. So that's going to equal and you might be inclined to round up. However, it's imperative that you don't because it's during the year. So this is just going to simply equal 2032 because you can't put 0.7 in a year in this answer. That makes no sense. And also you can't round it up because this investment happens, this like goal reached happens in the year 2032. It's almost over, but it's not over yet. So that's the year it happens in. So this is your answer. Voila. The next question we're looking at is paper 2, question 2. The sum of the first 3 terms of a geometric sequence is 62.755, and the sum of the infinite sequence is 440. Find the common ratio, or find pretty much R. So let's write down the first things we know about this. We know the value of the sum, and we also know the value of the infinite sequence. Sum of the sequence, in the infinite sequence. So first thing we can do is write these equations down, including these numbers that they've given us. So also, we know that this is a third term, so this is going to be sum of 3. So let's write it down. Okay, perfect. It's also important to note that this can be written like this. Oops, sorry. We know this because if you multiply this into it, it's going to be u1 on top and then 1, which is like the invisible denominator for all like whole numbers. Up here, u1 goes up here, and then 1 goes up here, but 1 times 1 minus r is still 1 minus r, so this can be written both ways. Then 440 equals u1 over 1 minus r. It's not the same formula because this one's infinite sequence, and this one's just the sum of the first 3 terms. And as you can see, since we know it's 3 terms, the 3 is going to go up here. Okay, perfect. Now the first thing we're going to do is try to find the easiest way to find the value of u1. So this actually easiest way through here, because u1 can very easily be isolated by multiplying both sides by 1 minus 4. Let's get this. Equals u1. Perfect. Now that we have u1, let's put it into this one. Okay? Because we'd only have our values that are still unknown. So let's bring this down. Oops, sorry. Let's bring this down and put 5 equals. We're going to use this formula. It's going to be a lot easier visually. Times 1 minus r. Perfect. Okay, so the first thing you can notice here is there's a 1 minus r here and a 1 minus r here. So a 1 minus r, if you were to put it into the fraction, like here, you could see that this is obviously on the numerator, and then this is on the denominator, which means that these two can very easily cancel out. Perfect. Now let's rewrite that to make it look better. Excellent. As you can see, we're getting somewhere. It's going to become a lot easier to solve. So now, next thing we're going to do is we're going to divide both sides by 440. 440. You can do this on a calculator. So which gives us a very lovely number. But we're not going to simplify it just yet. So don't simplify it because that's going to make your answer less accurate and you might not get points for it. So we're going to write it down wholly. 42625 equals 1 minus r3. Now it's going to be very easy. You have a 1 here, so you're going to subtract a 1 from here. Subtract a 1 from both sides, so we can do that easily. And then, since we're left with this r cubed, we're going to have to do the cubed root of, it's going to be negative 0.5 0.85735. Perfect. Let's do this. So you go into math. You can find the cubed root. Go here, press answer, and bam! This equals to negative 0.95, which is the correct answer to this problem.
Budget.
Okay, so question 4. It gives us that log base x of a equals 3, log base x of b equals 5, and a times b equals x to the power of p. It wants us to find p. So, by using basic log manipulation, we know that x to the power of 3 equals a. So turning this from a logarithm to a normal value, we know that x to the power of 5 equals b, turning this into a normal value. Therefore, x to the power of 3 times x to the power of 5 equals x to the power of p. So, x to the power of 8 equals p equals x to the power of p, and 8 equals p. Question 3. In this question, it says Sam invested $1,700, so we know that p equals 1,700, into a savings account that pays a nominal interest rate of r equals 2.74%. And it is compounded half yearly, so k equals 2. Sam makes no further payments or withdrawals from this account. Find the amount that Sam will have in the account after 10 years, so t equals 10. So we know the formula for interest rate is p times 1 plus r over 100 times k to the power of k times t, and that's going to give you your amount of money. So all we need to do for this first question is to plug it in. Your money equals 1,700 times 1 plus 2.74 over 100 times 2 times 20 to the power of 20, right? Because k is 2, t is 10. 2 times 10, 20. That should give us the money equals $2,231.71. So that's the amount that Sam has after 10 years. That's part A. Part B tells us that David also invests $1,700, but we don't know the interest rate that he has, and it is compounded yearly. And we want to find the R that David needs so that in 10 years, the amount will be equal to the amount in Sam's account. So we want to set up the formula so that it is equal to Sam's value. 1,700. And we don't know what R is. Over 100 times 1 to the power of 10. Okay, so all we need to do is to solve it. We divide both sides by 1,700, getting us that 1.313 equals 1 plus r over 100 to the power of 10. We take the 10th root of everything, giving us that 1 plus r over 100 equals 1.02759. We subtract 1 from both sides, giving us that r over 100 equals 0.02759. And then we multiply both sides by 100, giving us r equals 2.759. And since it asks us to give all answers to 2 correct decimal places, r equals 2.76%. And then part C, the final part, is to find the interest that David will earn over 10 years. And to find the interest, you get your final value subtracted by your initial value. So 2231, which is the final value, minus 1700 equals $531.71. That's the amount that David will earn over the years.
So now we'll be doing question 6 of the form. It says consider 4 consecutive integers, P, Q, R, and S. We know that they're consecutive, so we can infer that Q is equal to P plus 1, R is equal to P plus 2, and S is equal to P plus 3. And it says that the product of the inner two integers, so P plus 1 and P plus 2, will always be more than the product of P and P plus 3. And we have to find the difference of when the product of these two integers is subtracted by the product of these two integers. So let's set that up to make it P plus 1 times P plus 2 minus P plus 3. So let's distribute. This becomes P squared plus 2P plus P plus 2 minus P squared plus 3P is equal to A, and A is a common difference. So here, cross out P squared, cross out P squared. This will be 3P, so cross out 3P, cross out 3P, and 2 is equal to A, and that's your final answer.